So welcome back to part 2 of our lesson on using square roots to solve quadratic equations. I've got a question for you. I'm wondering for what values of k will this expression be factorable? So for what values of k will this expression be factorable? So put me on pause and have a think about what that could be. So if we consider the middle term and our last term in our expression, we know from our previous lessons that I'm looking for two numbers that add together to give me 12 and multiply together to give me whatever k could be or should be. And I know that my factored form is going to look something like this, where I have x plus or minus some number times x plus or minus some number. So what could those numbers be? Well, if we look at 12 and all the values that could be added together to give you 12, I know that when I multiply those numbers together, I should get k. So if I start looking for those numbers that create that sum, that would be a good place to start. So possible options could be like 1 plus 11, 2 plus 10, 3 plus 9, 4 plus 8, etc. So you get the drift here, right? So here's all my possible values. And then if I take these same numbers and I multiply them together, I should get all the possibilities of k. So if I had 1 times 11, that would give me 11, or 2 times 10, 20, 3 times 9, 4 times 8, 5 times 7, and 6 times 6. So that would give me 27, 32, 35, 36. So there's the list of all the possible values that k could be right there. Now, what if I asked you, I specifically want a perfect square trinomial. So I want you to pick k such that when I factor it, I will get a perfect square trinomial. So just remember that a perfect square trinomial is one that takes on this form, right? It's a binomial factor that is multiplied to itself, and it results in this form, right? So this is what we call a perfect square trinomial. So what would k have to be in order for that to be true? So have a think about what that might look like. If I am multiplying something to itself, that means that both of my factors should be identical to each other because I'm going to square them, right? That tells me that my number or my value that I'm looking for should be the same whatever this number is. And the only situation where that makes sense is if we have plus 6. So it's right here and it's right here. That means that k would have to be 36 in order for this to be a perfect square trinomial. So k would have to be 36 in order for this to be a perfect square trinomial. So if this was 36, that means that if I factored it, I would get x plus 6 all squared. So I want you to look at a couple more examples and tell me what k would have to be in order for it to be a perfect square trinomial. And I want you to think about perhaps something repetitive that keeps happening in that process. So I'm just going to give you 3 examples. And you tell me, what would k, the question mark is supposed to be a k, so I'll just put k there. So what would k have to be in order for these expressions to be factorable, and not just factorable, but for these expressions to be perfect square trinomial. So just have a think about that. Put me on pause and then check your work. So in order for x squared plus 10x plus k to be factorable, not just factorable, but also for it to be a perfect square trinomial, that means that I would have to have something being multiplied to itself. And the only factor that will allow for that to happen is if I had plus 5. So if I have x plus 5, I know that both of my inside terms, my inside and my outside term, when we FOIL, right, when you do this and this, these will be 5x plus 5x, and that will give me 10x. So that addition is there, and then that means that k would have to be 5 times 5, which is 25. So this would be x plus 5 all squared, and that means that k would have to be 25. In this next one, again, whatever 24 is, we're looking for this type of relationship where we see this repeating number appear again, and that's going to happen when we have 12 plus 12. So in this case, we're going to have x plus 12 times x plus 12. That's going to give me that, again, that inside-outside situation where I have 12 times x and x times 12, where I'll get 12x plus 12x, which will give me 24x. Therefore, this can be x plus 12 squared, and that means that k would have to be 12 times 12, which would be 144. So in this case, k is equal to 144. And in the last one here, same idea. We are going to have x plus, those repeating numbers are going to happen when I have 8 plus 8. And again, I have x plus 8 all squared. And that means that k would have to be 8 times 8, which is 64. So what are we noticing? What do all of these numbers have in common? So with this expression, with x squared plus 12x plus k, we have 6. This repeating x plus 6 all squared. And then for these guys, we've got these 5s, 12s, and 8s. So what is the relationship here? What's the repeating pattern? If you notice, my choice here for 6, because my middle term is 12, I chose 6 because it's exactly half of 12. And I know that when I add them together, I'll get 12, right? And it also generates the same number, which I can then multiply to itself to give me a perfect square trinomial. And the same thing is happening with these bottom 3 examples. If you take a look at my factored form, where I have this 5, 12, and 8, all those numbers are exactly half of 10, 24, and 16. And then the k value is just coming from those numbers being multiplied to themselves, being squared. So if I give you an example that looks like this, and I'm like, hey, what is this missing number going to be? It's pretty quick to figure out, as long as I know that, I just need half of 18. Well, half of 18 will be 9. That means I'm going to have x plus 9 all squared. And when I do that, I know that this number here will just be 9 squared. Okay? So in this case, this question mark, I know is supposed to be 81. Oops. There we go. I know that this question mark here is going to be 81. And I know that this is the same as x plus 9 all squared. And I know that this guarantees me a perfect square trinomial.